So, hello everyone. I have this one. Uh, my name is Milica. I'm a technical writer at Google on the Chrome team, and I work on many areas. One of them is identity and authentication. I've also been working on privacy and performance. So, if you want to chat about any of these topics, please find me in the lounge, and also you can find my articles on web.dev and developer.chrome.com. If you want to talk online, you can find me on Twitter at Vivid Digital, and you can also find my email on my personal website. Today, I'd like to talk to you about our future without passwords. And here's a little preview of what we will cover. We can talk about getting rid of passwords without first talking about passwords. With that out of the way, I'm going to tell you about the main topic of my day, which is actually passkeys. I'll tell you how they work, how they show you exactly how they work, and I'll tell you what kind of benefits they offer. We'll talk about one of their major benefits, which is security. We'll go over the state of support of passkeys today, and I'll show you anatomy of a passkey system and how you can implement it in your web app today. So, let's get started. Passwords have been around for a long time, but they're a pain for the users, and they're a liability for you as a developer. Strong passwords are difficult to remember, so many people don't bother creating strong passwords, or they use the same password for everything. I've done a little bit of research, and what I found is that bad habits die hard. 2/3 of people reuse their passwords, and 1/3 of them share passwords with others. Now, we really all struggle with passwords. Let's have a little show of hands. How many of you had to reset their password in the past few months? Right? And actually, we're not alone. 90% of people has to reset their passwords several times a year. In this survey, they actually found that 6% of people said they have to reset their passwords daily. So, yeah, the situation is dire. Now, I know what you may be thinking. Password managers help here, right? Like, I don't know which password manager you're using. Okay, I'm joking. No, password managers really do help. They can generate a strong password, they autofill it to exactly the right domain or app, and they can synchronize your passwords across your devices. That's all great. Password Manager can be a standalone app, it can be an extension, something like 1Password or Dashlane. It can also be built into your operating system or a browser. Google offers Google Password Manager, Apple offers Keychain. You know, we're a technical audience here. I'm sure a lot of us use Password Manager, but the reality in the world is not everyone relies on password managers. Okta has recently done a survey, and they found that 2/3 of people feel overwhelmed with the number of usernames and passwords they have to manage. Now, that aside, passwords are just not very secure. Passwords are one of the most common attacked surfaces, and 81% of hacking-related breaches is related to passwords. Now, as a developer, if you store passwords, you are the one who's responsible for the liability of hacking breach. And hacking is only part of the issue. Passwords are also susceptible to phishing. Now, phishing attacks trick your users into revealing their sensitive information. So, you know, like when you go on your bank's website and it looks exactly like your bank's website and there's a sign-in form, but the URL looks kind of weird? A lot of people will enter their username and password on that page. Now, no matter how strong a password is, it will get stolen on a phishing website. Now, phishing scams have been on the rise, and they've increased 12 times since 2016. Okay, now, I'm guessing a lot of you may be thinking, but we have two-factor authentication, right? And that's true. Two-factor authentication does improve security. However, one, this is an extra step for the users. And two, two-factor authentication costs you as a developer money. Now, that's why today I'm excited to tell you about the new technology that's simple and secure, and it's going to make it easier for people to sign in on the web without using passwords. It's passkeys. Now, passkeys are a simple and secure way to authenticate online without using the password. A passkey is a unique cryptographic key pair that's tied to a user's account and a site or an app. Here's a little example. So on sites and apps that implement passkeys, the browser or the operating system will show users a prompt to create a passkey. Now, what user needs to do is just touch their fingerprint sensor or any other screen lock feature on their device to continue. They don't need to type anything. They don't need to remember anything. Once a passkey is created, the next time they want to log into this app, they will be shown a prompt, and all they need to do is use the screen lock feature to verify, and they're in. So this is the key feature of passkeys. The browser and operating system will make sure that each passkey can only be used for the site or the app that it was created for. So this makes passkeys phishing resistant. Unlike with passwords, no one can trick users to sign into a sketchy app or website. Now, passkeys are developed by FIDO Alliance. This is an open industry organization that works on developing technologies that reduce reliance on passwords. Many major companies are part of FIDO, like Google, Microsoft, and Apple. And FIDO has been working on this for over 10 years. So passkeys are not a proprietary technology. This is an open standard that's being specified and made to work across platforms. Another thing FIDO does is conducts its research. So recently, they published a stat that 58% of people abandon purchases due to difficulty of managing passwords. So improving the sign-in experience actually has a very tangible effect on the business. Some of the benefits that passkeys offer are higher login success rates, reduced sign-in time, increased conversion rates, and reduced costs of separate two-factor authentication solutions. Many apps and websites already implement passkeys. Some of them are PayPal, Amazon, Kayak, and many others. Amazon recently published that with passkeys, their customers find it easier to sign in compared to passwords and codes. Now, Google Accounts users agree, and 64% of them find passkeys easier to use. Kayak, on the other hand, found that average sign-in time reduced by 50% for people who use passkeys compared to people who use passwords on their sites. Now, these are only some of the examples. The list of sites and apps keeps growing every day, and you can check it out on passkeys.directory. Now, passkeys have been around for a little while, so I'd like to do a little poll. How many of you have used passkeys before? Yeah, okay, cool. That's quite a few hands, more than I had last year. But it's not everyone, right? So out of you who haven't used passkeys, how many of you have a Google account? Right, you have a Gmail. Well, all of you can try out passkeys today. So just check out this link, and it will prompt you to create a passkey for your Google account. Passkeys are supported on Google accounts since May 2023 across all major platforms. So I really encourage you to try it because it's so easy and it will make the rest of my talk make more sense to you. I'm going to show you a little video demo of how passkeys work on an actual demo app. So let's say I have a fictional bank website. Let's call it TryBank. And I've signed in the old school way, username and password. However, my fictional bank is really on top of their game. They have implemented passkey support. So they're going to prompt me to ask if I'd like to create a passkey. I think better security sounds good, so I'm going to say yes. This gives me a dialog that lets me verify using my screen lock. In this case, it's my fingerprint. Once I verify, I touch the fingerprint sensor, And now a passkey is saved on my device. Now, next time I want to log into TriBank, I'm not going to use username and password. I will be prompted to sign in with the passkey. I'm going to select my passkey, confirm with my fingerprint, and that's it. I'm in. That was quick. So the major benefit of passkeys is that they offer a simpler user experience for users. There's no typing required. The account selector just shows you a list of credentials you can sign in. And you can sign in just by using your screen lock. Now, this can be any screen lock method. It can be a biometric one, like a fingerprint sensor or a face scan, but it can be other screen lock method, like a PIN or a pattern. Now, let's talk about security of passkeys. This is a major advantage over passwords. I mentioned passkeys work with public key cryptography. A passkey is a private key that's saved on the device, and it has a matching public key that's saved on the server. Now, there is no secret saved on the server, and this makes passkeys less vulnerable to server breaches, unlike passwords. So even if your server gets hacked and an attacker gets a hold of a public key, they can't derive the private key from that. Another thing that people often wonder about is that your biometric data is never shared with the server. The biometric data does not leave the device. The private portion of the passkey also contains metadata. Like I said, a thing that ties this passkey to user account and to the specific website it's going to be used for. Now, this metadata is what ensures that the passkey can only be used for the specific account on the specific website. Now, once a user authenticates, confirming with the screen lock, a passkey is not sent to the server to be matched. What you're sending is just a signature that gets matched to the public key on the server. So if that's a match, the server responds with yes, and you got it. Now, if this all sounds cool, you might be wondering, where are passkeys supported? Well, the great news is they're actually supported in all major browsers. So Safari, Firefox, Chrome, and Edge all support passkeys. But it's actually even better than that. Passkeys are supported on other platforms. So on Android, iOS, and Windows. This means passkeys work on both apps and websites. And another key feature is they can be backed up and synchronized by a credential manager. Now, this might be a new term, but actually, it's kind of a broader term for a password manager. A credential manager is your digital vault that stores your credentials, so both passwords and passkeys. So when a user creates a passkey on the device, it can be backed up by a credential manager, and then it can be synchronized on your other devices as long as you're signed in to this credential manager. So on Android, that's Google Password Manager. On Android 13 and below, users can save passkeys only in Google Password Manager. Other companies have similar syncing capabilities for passkeys created on their operating system. So on Apple ecosystem, that's Apple Keychain. As long as you're signed into your Apple account, you should be able to back up and synchronize your passkeys across your Apple devices. Now, a cool thing we've been working on is that starting from Android 14, you can actually use third-party credential manager as well. So if you prefer 1Password or Dashlane, you can use it. If you still use Google Password Manager, the passkeys that are stored and backed up by Google Password Manager are encrypted on the device and securely uploaded and shared across your user accounts. So as long as you're signed into the same Google account, you can use the same passkey across your Android devices. However, this means you can't use the same passkey on other platforms like Apple, Windows, or Chrome OS devices, even if you're logged into the same browser like Chrome. But we're working on it. We're working on making passkeys from Google Password Manager sync to all these platforms by the end of 2024. For now, if you're signed into Chrome on your Android device that has a passkey and Chrome on a different device, you will get a push notification that will allow you to authenticate on the device that has a passkey and log in on the other device that doesn't. Now, again, passkeys are not a proprietary technology. They're still developing, and the ecosystem is working hard on making this cross-device synchronization as seamless as possible. In the meantime, if you want to sign in on a browser on a device that doesn't have your passkey, you can do it by scanning the QR code on a device that does. So, for example, I can use a passkey that I have on my Android phone to sign in on my friend's macOS computer. The devices need to be close, and you can use your camera to scan the QR code and authenticate on the device that has the passkey. I'm going to try to play a little video that shows this. Okay, yeah, here we go. So I have a MacBook, Safari. There's an option to sign in with the passkey. I get presented the QR code, and then on the device that has the passkey, I scan the QR code, get prompted, and then I authenticate on the device that has the passkey. Now, a one-time signature is transferred onto the Mac, and you're signed in. There's no work needed on the developer side to enable this user experience. This is built into the browser and the operating system. Okay, so I've told you how great passkeys are, and you might be wondering, can we get rid of passwords now? Well, not yet. Passwords won't disappear overnight. Like any new beginning, the change to passkeys is going to take time. Password and passkeys will coexist for a time to come. I like to compare this to transition from cash only to card transactions. This took a while as well, but now at most places you can pay with cash or with card. Actually, in London, where I live, a lot of places accept card only. Now, the transition sometimes takes a longer time in a different place, Berlin, for example, but things do move. Last year in Berlin, I was able to pay by card in most places. I think the same thing is going to happen for passkeys. Now, another thing to consider, this is a fairly new technology, and for a time to come, there will be a lot of users with older devices or older operating systems that do not support passkeys. So, you should keep passwords for those users for the time being, but now is really the time to start introducing passkey support to offer better user experience and better security to users who have the capability to use. Now, let's take a look at the anatomy of a passkey system and how you can actually implement this in a web app. There are a few key terms when we talk about passkeys. One of them is a relying party. Now, a relying party is actually just a term for your website that's going to let users authenticate with a passkey. Now, this site's role is, one, create a passkey, then authenticate users with a passkey. So it has to operate the client, but it also has to operate a server and a backend where it's going to store a database of users and keep the public keys to get matched for this authentication. Now, to create the passkey, you also need a device, an authenticator. This could be your phone or another device like a tablet or a laptop. So a physical device that creates the passkey and that has a screen lock functionality that you will use to authenticate with them. And finally, a really important piece, a credential manager. So this is a software on the user's device. It can store and synchronize passkeys. Now, let's look at the system of a web app. So there are 4 components that are necessary to make a passkey system work. So first, you need a browser which can run JavaScript. Then you need the authenticator, which can create a passkey and which can authenticate users with the screen lock. You need the backend, which holds your user database and the public keys. And then you also need a front end, which is going to communicate between the browser and the backend. Now, let's look exactly how you integrate passkeys into your web app. So because this is the web, we actually use the standard API called Web Authentication API or Web Authent. This is just vanilla JavaScript. Let's say you have a user who already has an account on your app. They have signed in, have a username and password. You want to prompt them to create a passkey. This is the function that you would call. So it's called navigator.credentials.create. This function returns a promise. See, there's like a lot of space here. We need to give it some parameters. So the first key thing is RP, stands for Relying Party ID. So this is the domain of the site that you want to associate this passkey with. Once again, this is what prevents phishing. This passkey can only be used on this site. Next, we need some user information. This will be used to identify the user in your app and also to present dialogue to the user that identifies their account. So, user ID, this is a unique identifier for your database. So it shouldn't be any personally identifiable information. It's really like best to have a unique string. This is an array buffer, so any 16-byte value that's generated per account will work well. Now, name, this is what we're used to. It's typically the username. So it can be a username or an email. And this username will be used to show the display dialog so the user knows which account they're signing into. Now, exclude credentials. This prevents registering the same device by providing a list of already registered credential IDs. Next, setting authenticator attachment to platform means this passkey will be limited to authenticating the user through a built-in functionality, like a fingerprint scan, on a specific device. We set this because passkeys actually have an option to be saved on hardware security keys as well. These are called roaming authenticators. So because you can put your security key in your laptop or your mobile device, these are called cross-platform. We're not going to get into those today. So for a web app, you set it to platform. Require resident key true means this should work without the user having to input their username. And I skipped over the challenge. This is just a random server-generated array buffer, which prevents replay attacks. So it is required, but during registration, it's not really used unless you want to do attestation, which is an advanced topic that we're not going to cover today. Now, we have all the parameters. A passkey will be created after the user consents using the screen lock feature on their device. When this happens, the promise will be resolved and a public key credential will be returned to the front end. Now, front end sends this public key along with the credential ID to the backend to be saved and associated with this user to be used for future authentications. Now we have created a passkey. Let's see how can the user sign in with a passkey. So on front end, you call navigator.credentials.get. This is another function that returns a promise, and it needs some parameters. So here, you request the challenge from the server, just a random generated challenge that prevents replay attacks. Then you specify the RP ID, which specifies the domain that the user is authenticated for. And then mediation conditional allows the authentication dialog to only be displayed if there is a passkey on this device. And here's how that plays out. So when the user puts their cursor in the sign-in field, an autofill dialog pops up that presents both passwords and passkeys. If they choose a passkey, then authentication dialog pops up that lets them verify with their screen lock. If they do that successfully, the promise will be resolved, and then a public key credential signature gets returned to the front end. Front end then sends this to the back end, which matches it against the database. If it matches the public key that we have in the database, we're successful and the user can go in. Now, I mentioned the autofill dialog that can present both passwords and passkeys. Here's how you enable that. I love it because it's so simple. It's just HTML. So on your input field in your sign-in form, you just add autocomplete, username, web, authn. Now, if a user focuses on their input field, this will pop up both passwords and passkeys as part of the autofill dialog. Now, this will help users transition seamlessly between passwords and passkeys because the browser automatically offers them both options. So for step-by-step instructions, you can check out the workshop that's linked on the slides. You should take a picture and try it out. Now, if you don't want to go step-by-step and start from scratch, actually, there's a bunch of libraries that you can use to help you get started. So you can find them on a GitHub repo, Awesome Web Authn. There's a bunch of libraries that help you start if you're using TypeScript, Ruby, Rust, or other languages. Now, I didn't really have time to get into the server side, but there are also libraries available for different server-side implementations like Java and PHP. Okay, so let's recap what have you learned today. Passkeys are a replacement for passwords. You don't need to type in anything. The device will offer you an account selector and passkeys to sign in with. Now, you authenticate using your screen lock, and it could be a fingerprint, facial recognition, PIN, or a pattern. And a cool feature is passkeys can be synchronized by credential managers and accessed across your devices. Now, they're much more secure than passwords because they're based on public key cryptography and they're phishing resistant. So a passkey can only be used on the service that it's registered for. And best of all, they're supported on all major browsers and operating systems. So to learn more about passkeys, you can check out the documentation on this link on developer.google.com. We're well on the way to a passwordless future. By implementing passkeys today, you get better security, a better user experience, and happier users. Thank you for your attention. Okay.